In this video, we're going to be examining the models of long-run exchange rate. What determines the exchange rate in the long run? Let me start by a very, very simple model, a basic model, and see whether that provides a mechanism for predicting the future exchange rates. It's called law of one price. The idea is this. Suppose there's a product that is being transacted under perfect competition, easily traded, no barriers to trade, and is being sold in two trading countries. Let's say P star is the price in the foreign country and P is the price level of that particular product in domestic economy. And E is our exchange rate. Given the assumptions we've made about transaction costs between these two economies, it must be always true that P star is equal to EP, meaning that if we buy the good at price P in this economy, turn it into foreign currency, that becomes EP, we get exactly the same price for which the product is being sold in the other economy. The reason for this claim is what is known as arbitrage. If there's a price difference, somebody's going to make a profit. Buy in one economy when the price is lower and sell it in the other economy. If this is true, then we can always derive the exchange rate based on the ratio of the price of this good in the foreign country versus domestic economy. And if you can find products that meet these conditions and also their own prices are predictable, then we can predict the prices of those products and then use the ratio of the prices to predict the exchange rate. So E may be predictable because some prices may be predicted. But the question is that whether this is really a practical solution to predicting the exchange rate. And the answer is no. The law of one price, every product having the same price in two countries, and also having predictable price do not jointly hold. To give you an example, let's start with Big Mac that is being sold in many countries around the world, and its quality is supposedly the same in all countries, but its price varies a lot across countries. For example, here's the data collected by the magazine The Economist, which has been doing this for many years, checking the prices of the Big Mac across countries in local currency, turning them into dollars, and then comparing them. And you can see huge variation. There are countries where prices are about 50% higher than the United States, and then there are countries for which the price is much lower. In fact, the range, if you look at the map and the coloring based on the price difference with the U.S., you can see that the price could be between minus 50, plus 50, so a huge difference across countries in terms of prices people pay for the same product, the Big Mac. So thinking about the variation of the price of Big Mac, you can start formulating why prices are not the same. You cannot produce the Big Mac in another country, let's say in Russia, and sell it a moment later in the United States. There's some local aspect to the production that makes it difficult to sell this product in another country. And that local aspect, the fact that there's some part of the product which is non-tradable, allows the price to be different across places. And this is what prevents the law of one price to hold across countries. And it's not just the Big Mac. If you look at the price of parking, which is a very local good, non-tradable, the price varies tremendously place to place. Even within the same city, the price varies a lot. For example, in Amsterdam, you have the price of $70 per day in 2008 versus a tiny amount in Mumbai in India. Or look at this one, for example, price of a ride. This is also a very local good, local transportation. So in Stockholm in 2009, the price of a 10-kilometer ride was $5, whereas in Delhi it was about 10 cents. So the law of one price doesn't help that much, but that doesn't mean that it's not very helpful in understanding the exchange rates. This is why. Maybe it's true that the law of one price does not hold, but the deviations from law of one price could be random. Some products are in abundance in some countries but short in other countries. And as a result, in one country the price is cheaper than the other country. If these scarcities are random, then in each country some prices are higher, some other prices are lower relative to another country. We might be able to find another formula to predict the exchange rates in the following way. Suppose that we look at the average price of a basket of goods. Let's say in foreign country the price level is P star for a basket of goods. The price of the same basket is P in domestic market. So if this hypothesis that deviation from law of one price are random holds, on average our prices and foreign prices should be the same when they are turned into the same currency. So we multiply our price level by our exchange rate and we get it into foreign currency, and that should be exactly equal to the price of the same basket of goods in another country. If this is true, then we have a solution for predicting the exchange rates. We can predict our price level, foreign price level, and then divide them and get the exchange rate. Predicting the average price level in a country is easier than predicting the price of one product. The reason is relatively simple. Average price level is targeted by the central banks. The central bank decides, for example, in the US that they want an average price level increase of 2% per year. Similarly in Europe or other countries. There may be difficulties in achieving those goals, but we might be able to model how much the target might be missed and therefore have an idea how much prices might be going up from one year to the next. If we know that, then we can predict the changes in the P star and P in the two trading countries and use it to find out to what extent the exchange rate of our home country is going to be appreciating or depreciating. This is called the purchasing power parity hypothesis, meaning that the same amount of goods can be bought with the same amount of money in terms of foreign currency in both countries or in all countries. In other words, the real exchange rate, which is the ratio of domestic prices to foreign prices in terms of foreign currency, should be exactly equal to 1. But do we really see the real exchange rate equal to 1 across countries? To answer this question, think about the following. Suppose you have $1,000 and you want to buy a basket of goods and services with it across countries. Is the amount that you can buy in the United States, in Germany, in South Africa, in Brazil, in India, the same amount or not? And I think if you check the prices, you're going to see that's not the case. $1,000 buys very different amounts in these countries, the same way that the price of Big Mac was varying across countries. So far, I've offered you two theories that give us possibilities for predicting the exchange rates in the future, but are not practical. So they are based on hypotheses that don't seem to hold. But some economists have still hoped that there might be something to salvage from these theories. In particular, what if the real exchange rate, epsilon equal to EP over P star, is fixed? It may not be equal to 1, but it's fixed. And if it's fixed, then we have a huge advantage in predicting the exchange rates. If epsilon is fixed, then you can measure it once and then use the definition of the real exchange rate to find the nominal exchange rate. And remember that P and P star are relatively easy to predict. Then we have a relatively easy way of predicting the exchange rates in the future. This hypothesis is called relative purchasing power parity, meaning that it's not absolute. It's not real exchange rate is not equal to 1. The same amount of goods and services cannot be bought with the same amount of money across all countries. But the ratios of the amounts that we can buy with the same amount of money remain constant over time. Does this hold? So let's check the data. To do this, what I've done is that I have calculated the real exchange rate for 3 economies: Brazil, Germany, and Japan. And the foreign currency in this case is the US for them. And what I want to know is that whether the real exchange rate epsilon equal to EP over P star is constant for these economies. I've used the market exchange rate, and for P and P star, I've used consumer price index. And here's the outcome. So you judge whether this is a constant number or keeps going up and down, up and down. So it's not constant. The relative purchasing power parity does not seem to help. However, now we're arriving at our real model using what we've learned so far. This is the key. Epsilon may not be constant, but it has predictable trends. And if we can predict epsilon, we might be able to predict the exchange rates. It's not a fixed amount, but there are some factors that drive epsilon. And we can use those factors to figure out where the real exchange rate might be going. And price levels, remember, are relatively easy to predict. As a result, we can have an idea where the exchange rate might be moving. I'm going to show you also that the model that we've developed sheds a lot of light on what has happened in the past and gives us some insights about where the exchange rate might be going in the future. Let me remind you that epsilon represents how much goods and services you can buy in one country versus another. That also reflects the ability of producers in an economy to produce their goods and services at a lower cost.